Hello everybody, please accept my Eid Mubarak. So, happy Eid Mubarak to you all. Today, we are going to see that how to graph a cubic function. Okay, so how to graph a cubic function. So in this example, you can see that this example says that use the fact that x equals to 4 is a root of x cubed minus 7x squared plus 13x minus 4 equals to 0. Find a quadratic function, a quadratic factor of y equals to the same function x cubed minus 7x squared plus 13x minus 4, and hence sketch its graph. So here we have two things, that to draw a graph or to sketch a graph. To draw a graph usually mean that we do this graphic work on a graph paper, but while sketching we will do the freehand sketch on the plain paper. So first of all, this example states that use the fact that x equal to 4 is a root of this polynomial. So if you can see that if x equals to 4 is a root, then by factor theorem that you have already done in grade 9 and 10 and also in IGCSE, that x minus 4 is a factor of the given polynomial. You can say y equals to x cube minus 7x squared plus 13x minus 4. That means you can factorize this in the factor form of x minus 4 times the other factor, or also you can say factors. So here now we divide x cube minus 7x squared plus 13x minus 4. Now apply 1. So you can see that 1x is x, you can say, and minus sign is there, and then 1 4s are 4, and finally this is minus, this is plus, and you can see it leaves no remainder. So therefore, and just now we have seen that as we have divided by x minus 4, then we have now the term x minus 4, and other term we have is now here x squared minus 3 times of x plus 1. So here you can see that this is a quadratic polynomial, and therefore we can say that here this is a quadratic factor. So in this way, we can factorize the given equation first. So fortunately in this case, x equal to 4 is given as a root of this polynomial. If this is not given and you have to draw the graph of this function, you have to find the way to factorize this cubic equation. So now you can see that as x equals to 4 is a root, and then we have this sort of factor, and this is root only when you equate this equals to 0, that means it is y 0. So in this case we have two facts, one as x equals to x minus 4 equals to 0, and another as x squared minus 3 times x plus 1 equals to 0. And if you simplify this, it's going to be x equals to 4, which is already given. And by using calculator, you can find, by using calculator in this quadratic equation, that equates to 0, then your x value will be nearly equals to 2.62, and another value will be 0.38 if you are rounding off to the two decimal places. You can also take up to three decimal places. All right. So what we have here now, we have one coordinate on the axis as you can, if you use this, so it is y equal to 0 here, and here also this is y equal to 0, so that here x is 4. So one point you obtained is x equals to 4, then y is 0. And then another point, if you take here, this is 0.38. This 0.38, which is also at y equals to 0, that we have got it from here. And then third point that we have got is, it is 2.62 nearly, and then it has also happened at y equals to 0. And so we have 1, 2, 3 points. As any point we'll have, okay, our graphing work will be easy. So let's try for one more point at this time. So we took y equals to 0 and got these points on the x-axis. Now what if you put x equals to, if you put x equals to 0, then x equal to 0 means on the y-axis x is 0 everywhere. So we'll see, we'll be able to find one point on the y-axis. So if you put x equals to 0, then it's going to be y is going to be x cube. You can see here, this is x cube. X cube means 0 cube is 0, then another term 7 times 0 square is 0, and then third times 13 times 0 is 0, and lastly we have constant term, it is minus 4, so y is minus 4. So we have got one point on y-axis as well, 4. And now we'll check this value. So first of all, if I'm thinking of this value, for example, then 0, -4 is here, so I mark this point 0, -4 over here. And then next value near to the y-axis is, there is 0.38, so then I mark it here. All right. And then another value on the x-axis is 2.62, so I will mark it here. And then it is 4 also, so 4 is at this point. Okay. Now how does the curve look like? So what you can do here, you can see that uh, y is -4 for x equal to 0. What if you move behind of this origin along x-axis? For example, if I'm taking x equals to -1, for example, so I'm moving to the left of this origin. So let's check what happens if you move to the left. So this is our equation. So what you can do here, it is y equals to -1 cube, and then 7 times of, you can see that x squared, so you can write here -1 square, and then you can see here this is plus, this is 13 times -1, and then -4. And let's check what it is going to be actually. So it is cube odd power of negative number, that is -1, so it's going to be -1. And then this is 7 times of square of negative is positive again, positive, so it is 7 times 1 is 7, and then it remains -7. And then now you can see that it is -1 and times 13, and then 13 minus times -1 is -13, so you can write here -13, and then this is going to be -4. And lastly we have, it is 8, So minus 7, 8, and then it is minus 4 is minus 12, and this is minus 13, and it is minus 25. So you can use calculator to check or calculate the value beyond value of x beyond 0. So I'm taking at this point x equals to minus 1. So what I have seen that the y is still going down from here. If that will be positive value, if that will be positive value, while moving left from this y-axis, then our curve will move upward. But at this time, you can see that y is negative, so movement is towards downward. Okay. Next, I will check the a value between 0, x equal to 0 and x equal. You know that the curve passes through this point because at this point value of x is 0. But what happens before that? So we'll check between x equals to 0 and 0.38. Let's say that value as x equals to 0.2, and do the similar work that I have done by taking x equals to minus 1 in this polynomial, in this equation. Then what you will observe that this value is not going to be negative. That means y is not going to be negative. That means y is rising up. And as soon as it reaches here, y will be 0 from negative. Okay. And now we have worked for the point beyond this x equals to 0 or beyond this y-axis, and then between x equals to 0 to 0.38. Now we work between 0.38 to 2.62 because we have two coordinates values on the x-axis where the curve is supposed to pass through. So then what we'll do actually, we'll check value of x between x equals to 0.38 and x equals to 2.62. Then you'll see that up to 1 point something, then about 2, you'll see that it is again falling down. If you check like this, then your curve must be going this way. And after some times, if you increase the value of x, you'll see that the curve is falling down, and as soon as it reaches the point 0 for y-axis, that is for x 2.62, your point will be here. Now at this point you have to check that whether curve goes up or it goes down. So in order to do so, again you have to check the value between x is bigger than 2.62, because at 2.62 this is 0, and then between 3 point this is 387. So you take different values between these two, you will see that curve is not going upward, but you will see that there is negative value. For example, it is 2.62. If you put x equal to 3, for example, and in this polynomial, then if you calculate this, you will get negative value. It means this curve is descending down from here, from 2.62, x-axis in this way. So in this way, your graph for this equation is ready. But only challenge is that you can see in the graph, this is maximum point and this is the minimum point. Then what you have to do actually, you have to keep on checking the values of x between these 2 points, and then again rise up. Then these 2 points, you can see that between these 2 point gap is getting a smaller, and you have to see in each neighborhood. Then at some point you will find that this is the maximum value. So from that point, if you go slightly to the left from this point by taking the value of x, you'll see that your curve is falling down. And about the same point, if you take the value of x, for example, if it is here, it is 1.2 something, it appears like. And then about that point, if you move ahead, then you'll see that the value of y is falling down. That means you have to be sure that this is the maximum point, and similar work we have to do at this place to find the coordinate of the minimum point. So in this way, the graph for this function. Okay, guys, just gather these points that we have used just now while sketching the graph of this function. But here in this case, one extra thing, one convenient thing that we are going to apply calculus in order to find the maximum and minimum value or maximum and minimum point in the curve of this function. Because okay, guys, so alternatively we can see that the draw or sketch the graph of y equal to x cube minus 7x squared plus 13x minus 4, the same polynomial I'm talking of, by using calculus, that is derivatives of maxima and minima. So if you use this maxima and minima, our work will be easier than while finding the maximum and minimum point on the curve. And in order to find this maximum and minimum point on this curve, so first of all, we gathered all the point that we have used while sketching the graph of the same this polynomial, and then extra work that we'll do is that we'll find the maximum and minimum value of this function by using derivatives. So here your given function is y equals to x cube minus 7x squared and then plus 13x minus 4, and then if you find dy by dx, that means you are going to take derivative with respect to x to the both sides. So here it is x cube minus 7x squared plus 13x minus 4, and then if you find the derivative of this thing, then just you can use this formula that if you are going to find derivative of x to the power n, then after taking dy dx of this, you have to do this work n times of x n minus 1. So same thing we'll do here. So after taking the derivative of x cube, it is going to be 3x squared, and minus it is 2x only, so 7 to the 14x, and then plus 13, and derivative of x is 1, so 13 times 1 is 13 itself, and this is as this is a constant, so derivative of constant is 0. So dy by dx for this function is 3x squared minus 14x plus 30. And as you know that while finding the maximum and minimum point by using derivative method, we require second order derivatives as well for the same function. So second order derivative means we take dy dx of dy by dx. That means we are going to take derivative of this derived function. This is 3x squared minus 14x plus 13. So this side you can write the second order derivative as d2y over dx squared, and then this is after taking the derivative, if you take the derivative of this, so this is going to be 2x, so 2 3 are 6x minus 14, and this is constant, so it is 0. So second order derivative is going to be 6x minus 14. So let's now gather all the information that those points and the given function and its first derivative and the second order derivative. Okay, so we have gathered all the information. So now you know that for maxima or minima, dy by dx must be 0. That means you can see from 2 dy dx is 3x squared minus 14x plus 13 equals to 0 by using equation 2. And if you use calculator, you can you should know that this function in the calculator, how to find the value of x in this quadratic equation. And then by using the calculator, the value of x that we obtain is 3.387, and the value of another value of x is 1.279 that we are going to use in this graph, and that's why I have marked all these points here in this plain graph sheet. Now we have to check what is the maximum point, and what is the value of x where curve attains the maximum point and it attains the minimum point. So we have two values of x. We have to check that whether at 3.387 y is maximum or it is minimum. So usually if you check with this value and this value, you'll have two different things, that you'll have one maximum value on this curve, another as minimum value. Sometimes you'll have both maximum value. So this sort of maximum minimum we obtained by using derivative are also called the local maxima and minima. And absolute maxima and minima, you have to find the minimum and maximum point among all the points on the curve. Then those points will be called the absolute minimum or absolute maximum point. So here we are talking of local maximum and minimum. We check that whether at this point these values of x curve attains only maximum or minimum or both. So here, in order to check at what value of x the curve is going to attain the maximum point, then we take x equals to 3.387 in the second order derivative, which is in 3, and then we'll check that this is d2y by dx square equals, it is 6 times of this value of x we are going to take, so it is 3.387, and then minus, you can see here this is 14. Then go to the calculator, it is 6.3, this is 6 times 3.387 minus 14, and if you see here it gives you the positive value, that is 6.322. So this is 6.322. So this value is not important. We have to only see that whether this is positive or negative. So this value is bigger than 0. That means we have got second order derivative as positive. So if the second derivative is positive, so you can say that therefore the curve 1, you can say that we have named here 1, this curve 1 attains maximum value, sorry, attains, because it is positive, so we can say attains minimum value at x equals to 3.387. So we have tested for this value, and now finally, so there is a minimum value at x equal to this, so we can say that the minimum point, as x is already here, x coordinate, this is 3.387, and at this point what you can do, actually this is the this is x coordinate and this is y coordinate. That means this is input and output is this equation 1, that is y. So In this case, it is x cube minus 7x squared. So you can write here in place of x cube, it is 3.387 cube, and then minus 7x squared, then 7 times of 3.387 square, and then it is 13x, so plus 13 times of 3.387, and finally at last it is 4. Now go to the calculator and calculate this value. Your value will be that the minimum point you'll get, it will be 3.387, and then the y coordinate for this is minus 1.417. So minus 1.417, and this sort of point I have already kept here on the y-axis. So similar work you can do with this value of x equals to 1.279. So when you put this value in the second order derivative here, that is 6x minus 14, and then we have seen that second order derivative as negative, it indicates that x has, or the curve has maximum value or maximum point, or the curve has maximum point, you can say maximum point at x equals to 1.279. So in order to find the maximum point, what you can do, actually the x coordinate is already here, 1.279 we have taken, and now put x equals to 1.279 in equation 1, and then use a calculator or otherwise calculate it, then you will have the value of y. So 1.279 and the y value 3.268, this is the maximum point of this curve 1. Okay, once we have gathered all these points, including these turning points, you can just put this on this plane graph. You don't require this to the scale, but there should be proper placing. So you know that this is -4 at y equal to 0. So beyond -4, we know that uh, y will go further down from here. So it will cross this y-axis. And then as this is the maximum point, so the curve will rise this way. All the way, it will pass through 0.38. So this is 0.38 because at x equal to 0.38, value of y is 0. So it will cross this x-axis. And also here, as it is maximum point, so curve will rise towards the maximum point, and about this maximum point the curve will start descending, and it will reach x-axis at, you can see that, where y equal to 0. This point is 2.62, so then it will reach here. Now you are sure that this curve will not go up, it will go down, because this is the minimum point. And so curve descends like this all the way to the minimum point, and once the minimum point is reached, it turns off. Therefore this is also called the turning point. And at x equal to 4, y is again 0, then it will rise up and it will pass through y and it will go this way, a cubic graph. So once you have drawn this, this is good idea to go to a graphic software to check whether or not the graph you have drawn is correct. So let's see here in a Desmos software. So I have the same function here, x2 minus 7x squared plus 13x minus 4, and our graph looks like this in the way we have drawn here. So our graph looks fine. So let's check this maximum and minimum point on this graph. So here you can see that maximum point is 1.279 and the y coordinate is 3.268, and here in this graph also you can see the maximum point is 1.279 and 3.268, and let's check that the minimum point is 3.387 and y coordinate at this point is -1.417, and use we can see the same thing over here also, the minimum point. And at x equal to 480, then it is x equal to 2.618, or we can take 2.62 up to two decimal places. So this point is also matched. This point is also matched. And also you can see that at y equal to -4, x equal to 0, and it crosses this y-axis over here. So the graph we have drawn is correct. All right. And then if you like later, you can just make it a smooth, and then your work is over. All right. And this is one kind of cubic equation. You might encounter some another kind of cubic equation also, like in this form: y equals to x minus 1, x minus 2, x minus 5. So main objective that you have to find some standard points like this, and by using derivative it will be easy to find the maximum minimum points once standard points are found out, and also you have the turning points. Then you can draw your graph in a fraction. Okay, guys, I'm sure you'll now be able to draw or able to sketch the graph of different kinds of cubic function. So this is all for now, and thank you for your patience.